welcome to LearnCity. My name is Praise and I'm your mathematics tutor. And in today's class, we'll be talking about trigonometry ratios table. The trigonometry ratios table. Now, the standard angles of trigonometric ratios are the 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And the values of trigonometric ratios of standard angles are very important to solve trigonometric problems. Therefore, it is necessary to remember the values of these trigonometric ratios of these standard angles. Now, the sine, the cosine, the tangent of the standard angles are given below in the table, in which we have the sine, the cosine, the cotangent, the secant, the cosecant, and the tangent itself. And now, moving to the ratios table, where we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, for the angles, here we have angles. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, where we have sine, cos, tan, sec, cosec, and cot. Now, for the 0 degrees, when sine is at 0, so when we have sine 0, our answer is 0. When we have sine 30 degrees, we have it to be 1/2. Where we have sine 45 degrees, we have it to be 1/√2. When we have sine 60, we have it to be √3/2. When we have sine 90 degrees, we have it to be 1. Where we have cos 0, we have it to be 1. Where we have cos 30, we have it to be √3/2. Where we have cos 45, we have it to be 1/√2. When we have cos 60, we have it to be 1/2. And when we have cos 90, we have it to be 0. When we have tan 0, we have it to be 0. When we have tan 30, we have it to be 1/3. When we have tan 45, we have it to be 1. And when we have tan 60, we have it to be √3. And when we have tan 90, we have it to be infinity. Now, for the sec, when we have sec 0, we have it to be 1. We have sec 30, we have it to be 2/√3. Our sec 45 to be √2. Our sec 60 is 2. And our sec 90 is infinity. So we have our cosec. Our cosec, in our cosec, we have as cosec 0 degrees to be at infinity. We have our cosec 30 to be 2. We have cosec 45 degrees to be √2. We have cosec 60 degrees to be 2/√3. And we have the cosec 90 degrees to be 1. Now, for our cot 0 degrees is also at infinity. Our cot 30 is at √3. Our cot 45 is at 1. Our cot 60 degrees is at 1/√3 and our cot 90 degrees is at 0. Now this table, it is important to know them very well as they help in solving trigonometric questions because they are constant numbers that have been gotten to help in solving our trigonometric questions. And now we'll solve two examples today. So we have used the triangles below to find the 6 trigonometry ratios. Use the triangles below to find the 6 trigonometric ratios. Now we have to solve. So it is important to know that where we have the opposite, the adjacent, and the hypotenuse. Now this part, for this first one, this is our opposite, this is the adjacent, and this is the hypotenuse. For this case, we have this to be opposite, hypotenuse, and adjacent. Now, for the first one, we first find the other side. We find the other side. So we have here to be a square plus b square is equals to c square, where in which this is the Pythagoras theorem. We have this to be Pythagoras theorem, where we have this to be 6 squared plus 8 squared is equals to c squared. So we have this to be 36 plus 64 to be c squared, where we have this to be 100 equals to c squared, and we have our c to be 10. So our c is 10 here, where we have 10. So for the first part, we have sine theta, which is opposite over hypotenuse. We have it to be 8/10, where we have it to be 2/4, 2/5. We have it to be 4/5. Let me just draw our triangle here. We have 8, we have 6, and we have 10. We have cos theta, which is adjacent over hypotenuse. We have this to be 6/10, where we have this to be 3/5. For our tan theta, we have it to be opposite over adjacent. So we have this to be 8/6, where we have this to be 4/3. So our cosec theta, which is 1/sin theta, we now have 1/4/5, which is also 5/4. We have our sec theta to be 1/cos theta, which is 1/3/5, which is 5/3. And we have cot theta to be 1/tan theta, which gives us 3 which gives us 1 divided by 4/3, where we have to be 3/4, which is the answer for the first triangle. Now for the second triangle, we have, here is with 5, here is 1, and we have this to be unknown. So we have it to be 1 squared plus √5 squared, which is equals to c squared. Now in this case, this is our A, B, and C. So our C is with 5, where we have 1 squared plus b squared will now be 5 squared, because we usually have opposite plus adjacent to be hypotenuse. So we have 1 plus b squared to be root 5 squared, where we have, let's cancel this, we have 1 plus b to be b squared to be 5, where we have b squared to be 5 minus 1. We have our b squared to be 4. So where we have root, so find the root, where we have our b to be 2. We have our b to be 2. Now for sine theta, where we have our triangle to be this, we have this to be root 5, we have 1, we have 2, we have this to be opposite, adjacent, and hypotenuse. Then we have sine theta, which is opposite over hypotenuse. We have this to be 2 over root 5. We have this to be 2 over root 5. Where we have our cos theta to be adjacent over hypotenuse. What is our adjacent? We have it to be 1 over root 5. And we have our tan to be opposite over adjacent. And we have our opposite over adjacent to be 2 over 1, which is also equals to 2. And for our cosec, which is 1 over sine theta. What's our sine theta? We have our sine theta to be 2 over root 5. Here we have it to be root 5 over 2. We have it to be root 5 over 2. We have our sec theta to be 1 over cos theta. So we have this to be 1 divided by 1 over root 5, where we have this to be root 5 over 1, and we have this to be root 5, where we have our tan cot theta, which is 1 over tan theta. And 1 over tan theta is 1 divided by 2. So we have to be 1 over 2 to be our cot theta. And today we've explained how we can get the 6 trigonometric ratios from a right angle triangle. Thank you for joining us in today's class. Please subscribe to our YouTube channel, like and comment, and see you in the next class.